Bacteria and viruses. What's the difference? California State Standard 1.2.p. Explain how viruses and bacteria affect the immune system and impact health. More specifically, we will be focusing on the difference between viruses and bacteria and how they affect our immune system. For example, when we get sick or catch a cold.
Oh, I feel terrible right now.
Oh no, would this antibiotic work?
Wait, we don't know if he has a bacterial or viral infection.
Well, what's the difference? Aren't they all just the same?
Nope. First we have to understand the difference between a virus and a bacterium.
Oh, isn't one alive and the other one not?
Very good, Jonathan. Bacteria are alive, viruses are not.
But what does it even mean to be alive?
Oh. Siri, what does it mean to be alive?
Look, I just work here.
Don't you, Siri, I got this. Something that's alive has metabolic processes, replication, and a life-death cycle. Bacteria have these processes, viruses do not.
Oh, are those the only differences between those two?
No, that's only one difference. There are several differences to differentiate between these two.
Like what?
Well, for starters, they're much different sizes. Bacteria tend to be much larger than viruses. Here's an explanation from our good friends, the Amoeba sisters.
Petunia and Pinky are here to explain the anatomy of bacteria.
Bacteria are a great example of prokaryote cells. When you think of pro, think of it rhyming with no. It has no nucleus and it has no membrane-bound organelles. Bacteria still have a cell membrane and genetic material like the other cells, but no nucleus, no membrane-bound organelles, and antibiotics will target them.
Well, what does a virus look like then?
Well, here's another great visual from our friends, the Amoeba sisters.
Petunia and Pinky are back to talk about viruses.
In fact, viruses aren't even cells at all. You can't say a virus is a prokaryote or a eukaryote. It's not a cell. It doesn't have a cell membrane like all cells have. It doesn't have a lot of cell components. It's a non-living structure. In fact, viruses can't even reproduce on their own. So viruses, again, are not alive. It makes them very difficult to treat. But let's talk about what they actually have. What is their structure? Because they do have a structure. One thing all viruses have in common is that they have some type of genetic material. Now, this does not mean that they can reproduce on their own, but they're going to use the genetic material and force their host to reproduce themselves. This genetic material for some viruses is the form of DNA, and for other viruses, it's RNA. They also have some kind of protein coat, also known as a capsid. Capsid's a vocab word to think of. They can protect that DNA or RNA genetic material. Another thing to mention is that viruses are very, very small, much smaller than bacteria, and you typically are going to need an electron microscope in order to see a virus. Very, very small. Viruses can also contain other structures. Some of them package special enzymes with them. Some viruses have an outer envelope. So there's different varieties on what viruses can have, but the main thing is that they have genetic material and they typically have some type of protein coat, also known as a capsid.
Checkpoint! Question 1. What are some characteristics of something that is alive? Take a few moments to think about it. Some characteristics include metabolic processes, replication, and the life-death cycle.
Question 2. What are the two things that bacteria don't have? Take a moment to think about it. Bacteria don't have nuclei or membrane-bound organelles.
Question 3. What are two features found in all viruses? Take a moment to think about it. All viruses have genetic material such as DNA and RNA and a protein coat called the capsid.
How do you do? If you didn't do as well as you'd hoped, feel free to rewind the video.
So what happens when a virus or bacteria enters your body?
Well, because bacteria are alive, once they enter the human body, they can use the human body's resources and conditions to replicate themselves through a process called mitosis.
But don't viruses also do that?
No, because viruses are not alive, once they enter the human body, they have to use it to inject their own DNA or RNA in order to replicate and create more viruses.
So what happens when a bacteria replicate? How can I stop it?
You can take antibiotics. Antibiotics are a type of medication that inhibit bacterial growth or kill them off. Some examples include penicillin, amoxicillin, or ampicillin.
Well, why can't you use it for viruses too?
Well, viruses aren't alive, and so there's no growth that the antibiotics can inhibit.
I still don't get it. Do you think you guys can show me?
Definitely.
Oh, let's see what these antibiotics can do. Oh, my body is ready. Let's go.
I'm a bacteria.
Ah! That's right.
I'm a virus.
Uh-oh, a virus? Great.
Oh, now I get it. But let's do a quick check-in.
Checkpoint!
Question 1. How do bacteria replicate? Take some time to think about it. They replicate by using the body's conditions and resources in a process called mitosis.
Question 2. How do viruses replicate? Take some time to think about it. Viruses replicate by injecting their DNA or RNA into a host cell.
Question 3. What do antibiotics do? Take a moment to think about it. Antibiotics inhibit the growth of and kill bacteria.
How do you do? If you didn't do as well as you'd hoped, feel free to rewind the video.
Wait! WebMD tells me that I have a bacterial infection. Does that mean I can use this antibiotics then?
No! First of all, you should never trust WebMD. Second of all, you should never share antibiotics or any prescribed medication. Bacterial infections and viral infections share really similar symptoms, so you should always go to the doctor to diagnose your symptoms.
Main takeaways.
Bacteria are alive, while viruses are not.
Antibiotics work for bacterial infections but not for viral infections.
You should always go see a doctor for a proper diagnosis.
Thanks for watching.
We hope you learned a lot from our video.
Stay healthy and wash your hands, kids.